We're going to talk about lesson 52, history of evolution. We will be able to identify some of the key figures in inventing evolution. Now, one of the big things that we like to talk about science is we like to every so often take a pause and say, you know what, this is really good that we've learned about this particular idea, but who came up with it? Why did they come up with it? Evolution is one of the most important lessons to talk about, because evolution has so much controversy over the like 200, 300 years that the theory has existed. So understanding why there are these controversies, understanding how it came about, and it is pretty important. So I thought that I would quickly talk about that today and just go through it. Now these slides actually, today I had 5 classes, and out of all the classes I spent the most time on these slides. And the reason you might think, oh my God, there's going to be a lot of it's going to be really amazing and really cool animations. It's like, well, no, not really. The thing about this was hard was when I went to look at the textbook to say, okay, what do I need to explain? What do students really need to learn? It was full. There were 6 pages of information about this stuff. And I'm like, oh my God, my students are not going to want to read or listen to me go through 6 pages of information. And you know what? I don't want you guys to write down 6 pages of information worth of notes. So what I've tried to do, and this is what took me a very long time to do, is I've tried my best to condense the story of evolution to as few people and ideas as possible. I've tried to really squash it down into a quick, easy to swallow thing. And the other one as well is, it's the problem with those 6 pages is there was like, oh, there's this person, this person, this person, and there wasn't really a story, and it made it very difficult for, in my opinion, to learn and teach. So what I'm really proud of, and what took me a long time, is I feel like I've created a way to explain the history of evolution in a relatively succinct way. I would love to get your feedback at the end. I would really appreciate that. If you wouldn't mind at the very end of this lesson just saying, yeah, that made sense, but that middle slide about this was completely confusing. But I'm going to try my best to compress essentially 50 years of intense scientific debate down into 4 slides. So it's going to be interesting. I'm going to try and cut as much writing down as possible. I'll give you guys the context as I speak. But if you don't understand, like if you want to know more, I implore you to go look up these information, figure it out. But I can't necessarily go through everything. And there will still be a fair bit of writing down, but trust me, I have tried to squash this writing down to as few words as possible so that you're just recording the key ideas. Let's get started. So don't have to copy this down, but I wanted to start here. Charles Darwin is credited as the creator of evolution. If you ever hear about evolution, sometimes it's called Darwinian evolution. And so it really makes a lot of sense to say, who invented evolution? Charles Darwin. And I would agree that is a really good argument to say. But like all theories, it's very rarely one person. And however, a theory like this is rarely one person. It is the work of many scientists that slowly evolves into a grand theory. You see what I did there? Yeah, does anyone here appreciate it? Yeah. Anyway, so it's kind of, there is a saying that Sir Isaac Newton once said, which is, the only reason I've been able to see so far is because I've stood on the shoulders of giants. Implying the only reason this theory exists is because there are many people that are smart that worked on it. And I agree, the same thing is true of evolution. There are many people that have worked to come up with this idea. And because it's easy to write down in a textbook, Charles Darwin came up with evolution, it's very easy to ignore the contributions of so many other people. and they get forgotten. So this is going to be a time to talk about some of those other people that may have been forgotten that came together. Now, the best way that I thought to try and approach this would be to say where we start and where we end. Let's go. So where we start. This is where we started, roughly at the beginning of the 19th century. So we're talking about early 1800s. What we have in the early 1800s, I haven't actually put any dates here because I ran out of time. Plus, I don't think it's necessarily super helpful for you guys to know the exact dates, but I'm going to tell you around the early 1800s, the Earth is very young. They believe that the Earth is very young, so all the living things on Earth existed since the start. This goes super well with the narrative at the time, which was that, you know, there was a certain guy who, there was a certain, this goes really well with the narrative that there was a certain guy who created everything in the world, and, you know, and all of the animals. Essentially, we're talking about Europe, so we're talking about Christianity. Essentially, this is a very popular idea. It's like, hey, cool, like scientists think the Earth isn't very old, which kind of works if the Earth was created by, you know, a being called God and stuff like that. And, you know, all these animals, they were created like, you know, way back in the day. So, okay, cool. But we moved from this initial theory that the Earth was very young, that everything existed, to this theory of evolution. Over the Earth's long history, life originating from one organism slowly changed into the different species we see today via natural selection. And this is our idea of evolution. I'm going to give you a second to jot that down because I have put a pencil on the slide because this is where we're starting. This idea, hopefully you can appreciate, is very different from the idea above. The idea above, the Earth is very young, and this one, the Earth is very old. And the first one, life has just always existed, and the second one, life changed over time and slowly morphed into the species we see today from one original species. Very different from, you know, back at the start, God created all the animals and the fish in the sea and everything was good. It's like, well, okay, now we're sort of saying no. The fish in this, like if you go like the tiger, the horse that runs across the field, that was actually a change, an animal that changed over time. So it's a very, very different idea. We also get this idea that slowly changing to different species we see there by natural selection. We've already talked about what natural selection is, so this shouldn't be a bit of an idea. Now, this statement down the bottom, I made this statement myself, but this is pretty much what I believe. Now, the reason I wrote this statement is because it ties into a lot of changes that people came up with. And I think the best way to approach this problem, and the best way that I've thought to turn this into a story that we can all appreciate, is by asking 4 questions. Those questions are: when, what, how, and why. The first one we're going to do today is what. What do we mean when we talk about life? What are we talking about? Then the next one that I think that was really good is when. We've got this idea of a long history compared to a very young planet. Okay, how can these two go? When did this occur? When is all this time coming from? It's a time question. The next one is, okay, even if we do accept that animals change over time, how do they change over time? Are they changing by generations, or are they changing within one one animal, and then that animal then changes. The last question is, if they are changing, why do they change? What is the reason for this change? It doesn't necessarily make sense that they, why? What is causing these things? Why would you change? It's like, why aren't the animals just the same as they were? Why do some animals live and some animals die? So we're going to try and tackle these 4 questions over the next 4 slides. We've only got 20 minutes, so I'm hoping that we can get through all of them, but I'm going to have to make sure that I speak, at least keep up to pace. So we're going to start with the what, which is the green one. What is life? What are the types of life? Now, this is the first question that was answered, and this is probably the oldest type of question. The 2 scientists we have to thank for this is Erasmus Darwin and Carolus Linnaeus. Now, Erasmus Darwin, you might think that sounds familiar. It's got the word Darwin in it. Surely it's not related to Charles Darwin, and guess what? He is. This is Charles Darwin's, that should be capital D, granddad. His granddad actually started this idea of evolution before he even was born. So Erasmus Darwin says we all come from one common ancestor somehow. He has no idea how, but he suggests, and that's why underneath his picture I've got this picture of a I was going to use these at the end to summarize all the information. He's got this picture. I've got this picture of a family tree. Essentially what happens is that we know that we all came from one, he thinks that we all came from one ancestor. And he gets that information because ultimately he looks at all the dogs and wolves and things. Well, these things all look a little bit the same. All cats look a little bit the same, and all 4-legged things all look a little bit the same. In fact, all like animals look a little bit the same. And so he's like, maybe we all came from one thing and somehow we became different. And so that's how we get this idea of he actually writes a text about this, and that's where he comes up with this idea. So he gets this idea of common ancestors. He can't really explain how that works. He has no idea how that works. We're going to deal with the how later. At the moment, we're just dealing with the what. Now, the Carolus Linnaeus, he invents something called taxonomy. Now, you guys might remember this is actually straight from year 7. Kingdom, phylum, class, order, family, genus, species. Family, order, genus, species. Kids prefer chocolate over fresh green salad. I actually gave a chocolate frog away to my year 7s who could memorize that 7 in a list. But that's Kingdom. What he did is he invented a way that all organisms could be organized, like they could all be put in their own individual box in some kind of sorting system. He said, well, all of these animals that have 4 legs, they and eat meat, they go into this box. All of the animals that have 6 legs and have a hard shell, they go into this box. And because he was able to do this, it helped scientists sort of understand the similarities and differences. It helped them group animals, and so therefore helped them to show how different animals were related. And yeah, that's essentially, these guys are the 2 people that helped us understand what. So when we talk about life, we talk about different forms of life, talk about what type of forms of life there are. These are the guys that were sort of talking about that. And it sort of starts to ask the question, well, if all of these things were created at the same time, at the beginning of the earth, why are some things really similar and some things aren't? Why do some animals have things in common? Why do some plants have things in common? Why are there these similarities? And so that's the type of questions that are starting to get asked. But you know what? It doesn't matter, because at the moment, most historians believe that the Earth is 6,000 years old. Now, for those of you that have even a microsecond of, even those of you who has just the tiniest amount, those of you that are seeing my class, probably not paying attention, hopefully you guys know, right, the Earth's older than 6,000 years. And the answer is yes, the Earth is older than 6,000 years. I have got rocks, like I've got rocks in my house that are older than 6,000 years old. There was no way that the Earth is 6,000 years old. But that's what they thought at the time, which brings us to the next question. I'm going to move from what to when. Ladies and gents, if you need me to slow down, you need to let me know, but I'm going to keep powering through. When could these changes occur? So obviously we've got the, if you stick with the Ezra M. S. Darwin's idea that, oh yeah, you're changing, it's like, well, we need to have this time. You can't just change overnight. You can't just have a chicken and lay, like you can't just have a bird lay an egg and it turns into chicken, or have a frog jump out of the water and turn into something else, like turn into a crocodile. Those things don't just snap happen. So what we needed more time. And the question about time doesn't come from biology. It actually comes from geology. We have James Hutton to thank today. So James Hutton essentially suggests that the Earth has been around for a long time. And he suggested it slowly changes. Ultimately, the theory of the time was, hey, thanks to religion. For example, if you've got a sea, that's because God made a flood. If you have a mountain, that's because God saw fit to pull up the earth, and that would be it. And if you ever see a mountain, that's because of some massive earthquake that pushed the mountain out into existence. But what James Hutton suggested is he says, no, these things actually occur over a very long time. These things take time to happen. In fact, he starts to say, yeah, the Earth's probably older than 6,000, probably more like maybe even millions of years old. And so people start to go, okay, that's very different from what we've been thinking. By the way, guys, I know that I'm doing a fair bit of picking on Christianity and so far. If you guys believe in Christianity, I have no qualms with that. It's fine. You can have your faith. I'm just sort of trying to suggest what was going on with science. And because at this point in time, a lot of science was shaped by religion. Now there's a little bit more of a distinction. So yeah, there's also a very, very strong division as well between religion and faith. But we're not going to get into that today. Baron George Cuvier, he's a baron, that's pretty cool, suggests that maybe the deeper layers of rock are older and contain older forms of life. And he essentially brings up this new idea, which are fossils. So we start to see these old skeletons, and we start to say, well, these are actually old life forms. And if they're buried in a deeper layer, then that means that they are older than the newer layers. And this is actually something that I would teach if I've got a chance to go through geology with you guys. But unfortunately, for some reason, geology does not get taught in high school anymore, which is a real shame because I actually really like geology. A lot of science teachers don't like it. Like, oh, geology sucks. No, rocks are cool. I'm a bit of a nerd. So we then move on to William Smith. He's the last guy on this list. William Smith sort of finds in rocks, he looks in rocks and determines that animals live for a while and then die out and are replaced. So he's got this idea that animals live and then they die, they're changing over time. You're not just having animals pop out, and you are having some animals pop into existence and then they get replaced with different types of animals. So we've got a very interesting idea here. Now we're sort of moving away from all the animals were created at the start. We're now saying, no, actually, or organisms, they're sort of saying, no, actually, organisms change over time. And that sort of links up with this previous idea from Ezra M. S. Darwin that we've come from this one old organism and we've changed. So we're sort of building up this idea of evolution already. Right, I'm going to change the slide in about a minute, so I'm going to give you guys another minute to copy just the text down. You don't need to you don't need to draw the pictures because of course the photographs. As I said, I've got 3 pictures here to go, 3 icons to go along with these people to sort of suggest what they contribute. Hutton contributed time, said things are older. Ezra said the deeper you go, the older the fossils you get, so the older the life forms. And then, of course, you've got William Smith, who starts to look at the age of, he goes, well, you know, in this really slow down layer of Earth, we've got all these animals, but then if you look up further up, there aren't that animals. So maybe that species of animals died out. So we've got an interesting idea there. 15 seconds or more. So that's the what forms of life and when. How are we dealing with time? So we're actually at a point now where we've got a very, very long time scale. We've got we've sort of got this idea that animals change and die, come into existence and die out. So we're actually really close to getting a theory of evolution. And that's actually what happens. We get a theory of evolution, but not from Charles Darwin. We get a theory of evolution from, oh, by the way, before we talk about that, this is what I mean by older rocks. Have a riverbed here. We've got some water going down, and as time goes on, sand gets built up. And so now we've got an old, now what we've got is we've got an old rock on the bottom. We've got, you know, middle-aged rock here. And we've got new rocks sinking to the bottom of the river. Now, let's just say this dinosaur comes along, and then the dinosaur starts to die, and the dinosaur dies and falls in the mud. And then what happens is you end up with this happening. So now we've got we've got our we've got our old, we've got our middle age, we've got newer, and we've got the modern rocks, whatever. Let's just say that we then grow a tree here, and then the tree falls down, the tree dies, and then it then builds, then we get another layer, and then there'll be some more rocks that form here, and so on and so forth. So what we can say is as we go down, these are older. So if we look at these rocks, the dinosaur is older than the plants. And so you can sort of see, you can sort of use this to sort of say, how did this species become this species? Or how did this species become this species that will become this species? And you can sort of get that by just looking at the rocks and knowing how deep they were. And so that's what we the floor is evolving. That's what it looks like. And yeah, this is called these types of rocks, by the way, resisting the urge to teach you guys geology. These types of rocks are what we call sedimentary rocks. No, you don't want to be like the dinosaur. You're not going to be turned into a, oh my god, you guys are like the most depresso emo kids I've ever taught. Right, let's keep moving away from this. We will soon become rocks. Anyway, let's keep moving on to talk about this. How did life change over this time? We enter in, this is the third of the 4 slides. I've got 5-6 minutes left, so maybe I won't get to the very end of this, but I will at least to point this out. Jean-Baptiste de Lamarck, French naturalist, introduces our first theory of evolution. Now, this theory of evolution is not the theory that sticks around, but what he sort of says is animals change during their lifetime to suit the environment, and then they pass on these changes. Half of this is correct and half of this is wrong. Yes, animals do change to suit their environment and they do pass on these changes. But the part that's wrong is they don't do this over their lifetime. We know that. We actually used, that was one of the very first things I taught you guys. Evolution doesn't happen over one species lifetime. Otherwise, it would be like evolution from Pokemon. It takes a long time. The example that Jean-Baptiste Lamarck suggests was, grab a look at the giraffe. He says, the giraffe has, because of years of stretching to reach leaves, passes on this long neck trait. I really should have wrote that sentence a little bit better. But essentially what he's saying is that the giraffe is always reaching up to get the highest leaves, and because it's always reaching up, it's always stretching its neck, and so its neck gets longer over its lifetime. So then when it has children, it then passes that neck stretching trait onto its children, and so they start off with long necks, and that's sort of what his theory was. Now, Gregor Mendel sort of comes in here as well. If you remember Gregor Mendel, we actually learnt about him in term 1. He's the monk that sort of was looking at genes, and he was the one that had the yellow peas and the green peas. And so his traits, he suggested how traits can be passed on and sort of talked about genetics and gave the backbone for what would be essentially us understanding chromosomes, which allowed us to then tie genetics to evolution. That's what we have Gregor Mendel for, and he's now thinking about this same sort of thing. How does life change over time? He's like, oh, life changes over time because ultimately different plants pass on different genes and so on and so forth. Now, the last person I want to talk about on this slide is August Weismann. Now, Weismann or Weismann, I don't know what it is, ruins Lamarck's idea and shows how acquired changes are passed on. Now, I didn't write how he did this, but I'll tell you the story now. And that's why his picture is a rat. So we've got a rat, some peas, because remember he did his experiment on peas, and we've got a giraffe. Why has he got a picture of a rat? So what August Weismann did, it's a bit traumatic. He took a bunch of rats and he cut their tails off. And so he had, like, I don't know how many rats he did this to. I'd imagine a lot, maybe 50 or 60 rats, cut their tails off. Now you might say, oh my God, why would he do that? Because what he did is he goes, well, I'm going to change these rats during their lifetime. Now none of these rats have tails. So I'm going to look at what happens when they breed. According to Lamarck, if they breed, they should breed children which don't have tails, because they don't have tails, their children shouldn't have tails. It's a trait that should get passed on. And what do you know? Turns out that was a trait. Their baby mice did have tails. And again, that's because, of course, Lamarck's theory is about all traits, whereas Gregor Mendel starts to get this idea of what a genetic trait is. I was sort of thinking about this the other day. I was trying to think of, like, if I could make a question, an attendance question like this. It's like a mother has a tattoo of a dragon on her left thigh. What is the probability that if she gives birth to a child, the child will also have a tattoo of a dragon on its left thigh? The answer is, there is no chance. It's not possible. That's not how it works. So yeah, that's, you don't inherit tattoos, because that's and this is why I gave that lesson. That's an acquired change. Just like how, you know, even if like a giraffe stretches its neck over its whole life and gets a longer neck, that's an acquired change. That doesn't mean that their children are going to get it. That's where we have to have this idea of genetic traits. And so, can I change the slide? Are we good? Are we copy this down or not? Because I
Yeah, you
might
can
put up
change
the,
it.
what time is it? We got 3 o'clock, 3:06. You know what? I'm gonna have to leave it there. So I will finish up with, because I don't want to force you guys to stick around longer. We only have one slide left, which is a bit of a shame, but there was still a fair bit of writing on that slide, and then that would have been it. But what I'm going to do is I'll finish this off on Wednesday, and I'll add some more slide. I'll add some more maybe animations in here. But essentially, yeah, the idea is this theory of evolution is not that great, because even though it says how things slowly change over time, it's not explaining why these things change. It's not explaining why these things change and why certain animals live and certain animals die. And it doesn't explain why, these things happen over a lifetime. That's what Charles Darwin and Alfred Wallace come in to do at the very end. But as Samir would say, ding, ding, ding. Oh, he has said it. Oh, I called him. I said it just as I clicked on the chat. That's the end of the lesson. I will not get you guys to copy this down today. That's fine. Don't stress.